So I'm going to talk about grapevine water requirements for yield and quality, for lack of a better term. I'll show you two contrasting scenarios where we did essentially same work, one in Oakville, one in Merced County in the San Joaquin Valley. So a lot of the times, these practices are combined with canopy management methods, and grapevine does need a suite of canopy management practices, and they do start with dormant pruning, and then we move on to green pruning, depending on what climate you might be. These might include shoot removal, leaf removal, and sometimes cluster removal is also done. I work a lot with flavonoid chemistry. Exposure to sun and exposure to water deficits may have a beneficial effect. But most of the time, we're managing exposed leaf area in grapevines, and we're managing the exposed leaf area for carbon dioxide assimilation. And this is how we initiate ripening and get the yield precursors into the mix, and the canopy microclimate will condition the fruit composition, and we do these suite of managements also to reduce the incidence of fungal infections. Irrigation requirements are driven by transpiration from these canopies, and as mentioned today earlier, the simplest way we can assess this is through an estimation of the leaf area. So from Alex Levin's presentation earlier today, you have seen this figure. Solar radiation is what drives grapevine evapotranspiration. This is from one of Larry Williams' paper from early 2000s. And then in this case, as Alex explained, there's net radiation, and then ambient temperature on the y-axis. And then as Alex showed earlier, the water use will decline with depletion from the soil profile. And then different applied water amounts was applied in this case. And y-axis midday leaf water potential, and then x-axis day of year here. Different applied water amounts in either case will be depleted, or will introduce stresses into the grapevine. But overall, water deficits do affect grapevine physiology. You do have changes due to dehydration. Abscisic acid accumulation will increase. Solute accumulation might increase. But as deficits increase, photosynthesis will decline, so will stomatal conductance, protein synthesis, wall synthesis, and cell wall expansion will also decline. And what we mainly work with in wine grapes, other than dealing with the green tissue or some of the other primary metabolites, we do work with the secondary metabolites, especially with the red wine grapes. They do all come from the same pathway, and the water deficits might enhance the proportion or the contribution of the flavonoids and flavonol compounds in the grapeberry skin. And there are two parallel stream pathways that might be upregulated depending on the constitutive flux or the deficits that we might impose on the grapevines. Most of the time, what we do is we will expose the grapevines to a certain amount of deficits to upregulate this portion of the pathway, the one on your right. And we do say that these compounds are more stable. They will have a less oxidative potential. And we have started seeing the similar response also in the flavonols, which are yellowish, colorless compounds that do act as solar protectants. A lot of the times we do worry about proanthocyanidins or tannins, for lack of a better term. We do use them as a point of ripening precursor, taste precursor. They're important because of their astringent properties. But as you will see, through the years, we have not seen that much of a benefit or an effect of deficits on our proanthocyanidins. So I'll show you this work in greater detail in the second portion of the lecture. In this case, we looked at leaf removal and applied water amounts and their effects on tannin composition and quantity and molecular mass. As molecular mass of proanthocyanidins increase, you might associate that with a higher amount of astringency, a tactile sensation. In hot climates, we do see beneficial effects of leaf removal and applied water amounts, but rarely do we see an interactive effect. The effects seem to be quite independent from each other. So first, I'll show you the case study in Oakville, which is kind of a special case because all our deficits and stresses seem to be occurring at the correct time, whether we apply deficits or do not apply deficits. So in this case, we looked at 3 leaf removals. These were applied mechanically, control, pre-bloom, and post-fruit set. And we looked at 3 applied water amounts, 25%, 50%, and 100% of ET crop replacement. These amounts were based on the from unrestricted or unstressed grapevine, where we calculated the crop coefficient, and then we applied a portion of that coefficient to these treatments. This was conducted at the UC station. This is a bale loam soil series, and of course, the spacing is fairly standard for our area. So we monitored quite a bit of stuff, for lack of a better term. So primary metabolism, we looked at the canopy, plant water status, gas exchange, yield components, and berry chemistry. And secondary metabolites, we looked at flavonols, anthocyanins, and proanthocyanidins. And I still work a lot with vineyard mechanization. This was probably the first time, a mechanical leafer went through these, high-value vineyards. So I thought they were going to kick me out of Tocolon, but it did work fairly well in this case. So our case in the Napa Valley floor is not that much different from other warm climate or hot climate areas, if I dare say so. I'm showing you this figure here. The x-axis is day of year. Green is growing degree days. This is the average last 10 years prior to this work being conducted. The dotted line is the growing degree days that was accumulated in 2017, and we're approaching roughly 2,000 growing degree days in 10 degrees Celsius. So it is quite hot, and we're approaching Lodi area thermal degree days. The other thing that we started monitoring at UC is the number of clear sky days. We have the luxury of having the CIMA stations spread across California. Now we can calculate this through basic our program or our loop. We can calculate the amount of clear sky days. So I have a lot of people from Europe in my lab, and for some reason they all go to Burgundy to study, and they come to California and they say, like, how come there are no clouds? I'm like, well, if you're from southern Spain and Italy, you should be used to this. But we have, over 300 days with clear skies. So we have hot days, hot years with clear skies, very high intensive gain. And then the other thing that we keep seeing are these intermittent heat spikes that might last 2 to 4 days. Okay, and these 2 to 4 day heat spikes when ambient temperatures are above 110, 120 degrees, even in the Oakville AVA, these might be events that we might consider to watch out for. But anyways, here's the estimated crop coefficient from this trial. This is a typical vertically shoot position canopy. I did not plot this on growing degree days, but this is a day of year. Here's an estimated crop coefficient for 8-foot spacing. We're approaching roughly 0.5 to 0.6. So the modeling here that was done based on the lysimeter and other published work works fairly well. And as Professor Williams showed, we are very careful about recording these between bud break to a fruit set to a veraison, and a veraison to a harvest. And then the applied water amounts, these are liters per vine. And then they're summed here in the middle for 25%, 50%, and 100% of ET crop. So there's the inherent linear degradation or gradation in these applied water amounts. And the plants respond fairly well. And we heard this today over and over. We might not want to start irrigating before leaf water potential reaches close to negative 10 bars. And here's our situation in Oakville. We do not necessarily hit these amounts probably till about June, early June to mid-June, and only after then we start irrigating. So these are stem water potentials. So you can add 2 bars to these to get to a leaf water potential. But early in the season, after bloom, probably close to flowering, we're roughly around negative 6 to negative 8 bars. So there are not a whole lot of deficits. But these are cracking soil, so they do dry down quite fast. And it's difficult for the grapevine to extract water out of these. But the treatments did not start separating till about the 25th of July. So it's very difficult to impose these deficits, especially with the 110R type of rootstocks on the north coast. But in the end, they did separate fairly well. And this separation was quite consistent. So this is showing the applied water amount treatments, 25%, 50%, and 100%. The other figures the leaf removal treatments, where we removed about 20% of the leaf area, which is quite common. And we still do not see a significant effect in the plant water status. However, canopy microclimate at veraison in these cases do have an effect. This is a control, pre-bloom leaf removal, and post-fruit set leaf removal. We are able to see a change in the number of contacts with a rod going through the canopy to assess how thick these canopies are. And of course, as you apply leaf removal or do not apply leaf removal, so this is just another way of seeing this, that the treatments are quite working. And here are the clustered number of contacts with a 1 meter rod, and we are able to see differences from side to side in these canopies. However, since the vines never really dried down until about 25th of July, as we were removing these leaves, the canopies were closing till we were able to get some sort of deficit on these. And we did see a lot of vegetative compensation of these canopies. And this is a quick and easy way to assess these. If you fancy yourself a viticulturist, you can just calculate or weigh the mass of lateral shoots at a harvest of these treatments. So control and pre-bloom had the same amount of laterals at a harvest compared to a post-fruit set leaf removal, which was applied about 6 weeks later than the pre-bloom treatment. In this case, this was kept open much later than the pre-bloom leaf removal in the Oakville AVA. But these are grown for wine grapes, ideal with all kinds of people on the north coast compared to my time in Fresno, and everybody's obsessed with berry mass and extractable anthocyanins, so on and so forth. But here's how the berry mass develops under different water deficits. So this is another way of confirming that applied water amounts were applied correctly. So compared to control, which is 100% of ET crop, we're supposed to see this gradation between them. So our greatest berry mass is reached roughly about 3.5 weeks prior to harvest, after which point the berry starts dehydrating, and you start essentially losing yield. But everything's working as it's supposed to, as far as berry mass is concerned. Conversely, when we look at the leaf removal treatments, we do not see any effect in berry mass development. So there's a lot of published work coming from cooler or, in fact, cold climates, where people are seeing a lot of differences in pre-bloom leaf removal, reducing berry mass, amount of berry sets, so on and so forth. So this is the second trial that I have done. We do not see this. My handsome friend from Fresno will talk about it tomorrow, George Zong. We don't see it in the hot or warm climates that berry set or yield is affected by leaf removal timing. This is a net gas exchange. The first inset is applied water amounts. This is stomatal conductance. Stomatal conductance is behaving as we expect. The more water we apply, the more stomatal conductance there is. The more water we apply, the more net carbon assimilated there is. However, there are some times that these are dropping, increasing, dropping, increasing. So a better way to express these would be to integrate these over time and put their integrals over a time point, which I will show you later on in the day as we talk about the spatial variability of these processes. But long story short, everyone talks low yield game, but no one wants to give up yield. So here's a look at components of yield. In this table, we're looking at irrigation first, 100%, 50%, 25%, and then leaf removal. We are seeing significant responses to irrigation. So these are linearly declining as we decrease the applied water amounts, which is well known. We're not seeing that much of a difference in skin mass of these berries. So there was a lot of talk about you can make thicker berries, so on and so forth, with different applied water amounts. It does not necessarily hold true in the Oakville AVA. Same thing with leaf removal. Berry skin mass is not necessarily affected with this. Our cluster mass is, of course, going to reflect what we saw in the berry mass. And here's the other parameter that we look at very closely, number of berries per cluster at harvest. So you can loosely translate it as how much was set, with these treatments. But neither applied water amounts or leaf removal affected the number of berries per cluster. Clusters per vine, of course, are not going to be affected. So yield, in our case, was only affected by applied water amounts, not necessarily leaf removal. So leaf removal timing, if this is something that you want to do or want to participate in North Coast, it's not necessarily going to affect yields. But I want to point out one thing here. 25% ET crop yield is the lowest, right? So between 50% to 100% applied water amounts, there's no difference in yield. So the trick then becomes identifying the correct amount between this 100% ET crop replacement and 50% ET crop replacement. I don't know that many people that will apply 1,800 liters of irrigation water per vine the whole season. So this is clearly out, but 8.1 kilos to 8.3 kilos, there's not that much difference. So 50% ET crop replacement in Oakville AVA seems to be a good compromise using the Larry Williams method in this case in experimental situations. So, of course, one thing that we look at is vine balance. This is the Ravaz index. The range is between 4 to 13 kilograms per kilogram yield to pruning weight ratio. So here are the thresholds. Anything below 4 would be undercropped. Anything below 13 would be overcropped. Most of the grapevines we grow on the North Coast are source limited, so we hardly reach these, crop load indices above 13. But what we are seeing is an invigoration with applied water amounts with a pre-bloom leaf removal treatment. As we increase the applied water amounts with a pre-bloom leaf removal to 100% ET crop, we invigorate, which, indicates that we have a higher crop load index compared to our post-fruit set. As we increase applied water amounts, we devigorate these vines. So it's working in opposite directions. So berry chemistry, we'll start off with the primary metabolites. This is total soluble solids, or as measured by Brix. This is their development. It's constantly increasing, and they finally start separating. So 100% ET crop has a little bit less total soluble solids by the time we decide to call it a harvest. But it's statistically significant, but I don't know if I would call it horticulturally as significant. Leaf removal treatments essentially had no effect. So here's the anthocyanin content and concentration. So content and concentration, it's a battle between winemakers, I guess, and plant physiologists. So here's the skin mass. They're all the same. Whether you do irrigation or leaf removal, there's no statistical difference. When we express total anthocyanins as content, milligrams per berry, applied water amounts do not affect it. So it's not necessarily a biosynthetic response. Same thing in the leaf removal treatment on the North Coast. When you look at total anthocyanins, milligrams per gram of fresh mass, we start seeing a response. In this case, as we reduce the amount of water we apply, we start getting more concentration of anthocyanins. So in this case, this was not a biosynthetic response, but in fact it was a concentration or a dehydration response with a Cabernet Sauvignon. So when you look at the kinetic development of these total anthocyanin concentration, so here's x-axis, these are days. We measured it starting at roughly around 8 Brix. You reach a peak right around the 17th of August, which no one will pick at 18 Brix. It stays constant there, and then they will degrade because they're hanging out in the hot California sun. But in the end, they're still quite different based on the applied water amounts. And we do not see a response from leaf removal with Cabernet Sauvignon and Oakville. When you look at their hydroxylation, irrigation, applied water amounts does affect this. We see more stable compounds with 50% and 25% of ET crop. With 100% of ET crop irrigation replacement, we do see more dihydroxylated, pinkish, reddish anthocyanins. Leaf removal, again, did not affect the hydroxylation of anthocyanins. So there's an inherent relationship between total soluble solids and total anthocyanins. This would be another way of looking at the biosynthetic response of these grapevines to these different treatments. So here's Brix on the x-axis. Here's total anthocyanins on the y-axis. We do not see any separation on how these develop with leaf removal treatments. When I look at it with applied water amounts, I do see that 100% ET crop, it's not making as much anthocyanins. because it's diluted. It does not have as much total soluble solids put into the berry. Conversely, 25% ET crop and 50% ET crop, the relationship is stronger there. We did start paying a lot more attention to flavonols in the north coast of California because our light conditions are changing. We are seeing more ultraviolet light B, which does condition the flavonoid profile of grape berries. In this case, we did not see a whole lot of response to flavonols, to irrigation amounts with to flavonols. However, since these are light receptors, for lack of a better term, we did see a response to leaf removal in this case. We did see a biosynthetic response. The highest amount was in the post-fruit set, followed by pre-bloom, but pre-bloom leaf removal was not that much different from control or post-fruit set, which in case there was a lot of vegetative compensation with this. So when I look at the kinetic development of total flavonol content, I do not see any statistical separation in these over time. But with leaf removal, I do see a separation with these. Then we come to the tannins. So here's a berry mass at harvest. These are different by applied water amounts. Leaf removal, these were not different. Total proanthocyanins or total tannins, this is milligrams per berry, and this is their concentration. I don't know if I would call this statistically significant because it will not pass a review. They're somewhat different at the 10% level, but 25% ET crop, this indicates to me that the tannins had degraded to a point that they would not be very astringent. And we did measure that as well. So astringency can be referred to as the mean degree of polymerization of these tannins in the grapeberry skin. So here's terminal and extension subunits. In the terminal, you have catechin, epigallocatechin, epicatechin gallate units here. The only difference here was with the EGC, which would give you drying sensation on the tongue, and the drying sensation was highest if you applied 100% of ET crop. But again, the mean degree of polymerization was not affected in this case. Leaf removal, not much home to write about here on the north coast with leaf removal, but this is very highly managed, strictly grown for monovarietal Cabernet Sauvignon production. So I'll turn the tables around and I'll show you a massive production study that we did in Merced County. This was done with Merlot on Freedom. This is a typical 7 by 11 foot spaced vineyard, drip irrigated. Oddly enough, this vineyard was head trained and cane pruned, but it was we tried to manage this mechanically. So this generates this canopy such as this, where you can drive through with the tractors. But the grower's concern was that it was not making the grade even to a blend. So this was, of course, managed mechanically. So we applied mechanical leaf removal, opened up an 18-inch window within the canopy. Again, similar treatments: no leaf removal, pre-bloom, post-fruit set, about 200 growing degree days and 600 growing degree days when they were applied. And even in head-trained canopies, they do work fairly well. And this was a post-fruit set leaf removal application. You can see that the the leaf removal opens it up fairly nicely. And the irrigation treatments here were based on the same method that I showed you earlier. I won't go into too much detail. We applied sustained deficit irrigation or regulated deficit irrigation. And regulated deficit irrigation, in this case, we applied 80% of ET crop from bloom to set, and then from veraison to harvest. From set to veraison, we only replaced 50% of ET crop in this case. So when you look at this, this work was done during California's last historic drought. I'm only showing you 2 years of the work. This work continued till 2015. In 2013, we had 61 days above 32 degrees Celsius. 2013, we had 10 days. 2014 was a much hotter year, which is of concern. Seasonal water applied water amounts. 2013, we had a decent amount of rain that was concentrated in the earlier portion of the season. The applied water amounts are indicated in the lower portion of the figure. The top line is the sustained deficit irrigation. The bottom line is regulated deficit irrigation. So this 6 to 8 week of stress, dropping it down to negative 14 bars of midday leaf water potential, had worked for us previously in our work. Here's the following year, where we had a much more erratic precipitation pattern as the drought started taking control. So here's the midday leaf water potential. So Michael Cook, who came here from Texas, he's painstakingly measured these over many weeks, and we were able to get a decent separation between sustained deficit irrigation and regulated deficit irrigation in both years. But in 2014, our leaf water potentials started at a much less stressed phase. As these were managed mechanically, we were able to see the responses of leaf removal. Pre-bloom drops the amount of leaf contacts to essentially half of what they were, and then when we apply the post-fruit set leaf removal, it does drop them again. But what we saw that was more interesting here in the hotter climate in the Merced County in San Joaquin Valley was that pre-bloom leaf removal, there was hardly any vegetative compensation in the hot climate, because we were under these deficits much more consistently. So this is always a matter of debate, functional leaf area. The mechanical severity, we are removing about 20% of the leaf area. We're reducing it by about 20%, so we should see a photosynthetic response. If I chop off 20% of my body, I would see a response. But removing about 20% of the leaf area is not necessarily ending up in differences in yields, but it's influencing the light transmittance, especially early in the season with pre-bloom leaf removal. The responses are consistent over years. So these vegetative compensation response, even under deficits, is significant. This is a critical factor in determining the lasting effects of improved cluster microclimate and yield status. Pre-bloom leaf removal, recovery responses are observed, but it is incomplete in very hot climates. Post-fruit set, in 2013, the vines refilled soon after defoliation. 2014, recovery occurred, but they did remain more open, because 2014 was a much hotter year, like I mentioned. So when we look at yield components, we do see a response to leaf removal in the hot climate. Okay. However, the response is not consistent with berry mass over years. Berry skin mass, we see a consistent response in the hot climate, where we have a bigger berry mass with a pre-bloom leaf removal in both years. Yield, when we express it as kilograms or pounds per meter or foot of row, there's no significant effect in the first year. In the second year, we saw a decline in yield with the post-fruit set leaf removal, probably due to the overexposure in the hot climate. When we look at chemical composition here, not much home to write about here. Since these were valley grapes, the target was to pick them at like 24 bricks. The control vines, since they had a little bit more leaf area, they did come in earlier, pre-bloom, at the same time. Post-fruit set is a little bit different. Juice pH, titratability is not that different. Sustained deficit versus regulated deficit. We do see a benefit with our regulated deficit where they would come in earlier. In 2014, we did not see a difference in leaf removal, but we did see the benefit of deficits that we applied, where our regulated deficit was accumulating a little bit more sugar by the time harvest comes. So the main goal here with the grower was to look at the tannin composition here. In this case, I'm showing you in the first inset on a berry weight basis, milligrams per kilogram of tissue weight on the berry is monomeric catechins, epicatechins, total skin flavonols, and total skin anthocyanins. We're seeing the benefits of the leaf removal. However, we did not see a whole lot of response to applied water amounts. In the second year, the situation reversed. We did see a benefit again of the leaf removal, but not a whole lot with the applied water amounts here, probably because the difference between sustained deficit and regulated deficit in this case was not that much different. But we do start seeing some benefits when we start expressing them biosynthetically, and this is kind of follows up with what Alex Levin said, that some cultivars will behave differently, and in this case we do see that Merlot can behave much differently than Cabernet Sauvignon under these deficits. So when we look at the tannins in this case, here's the astringency, the mean degree of polymerization. We do see a benefit of increasing astringency in this case with post-fruit set leaf removal, but we do not see any effects with applied water amounts. The second year, we do see the same response with leaf removal, but again, no response with applied water amounts. One thing that a lot of the growers are concerned about is the conversion yield of tannins. The conversion yield meaning that how oxidizable they are, and how if they will peter out in the bottle after you make these into wine. So when you look at the leaf removal in the initial year, we did see more conversion yield with post-fruit set. But compared to pre-bloom, it was not that much different. But what rang true with a lot of the people when they saw this work was the labor operation costs with this. All the vines were pruned the same. Leaf removal cost changed on a per hectare basis, whether it was applied or not. Irrigation applied, megaliters per hectare, or acre foot, however you want to convert this to. And irrigation cost changed depending on how much we applied. Total skin anthocyanin production, how much anthocyanin we were producing per hectare. You can do nothing, prune these vines and irrigate them as you wish. You're going to make roughly about 2 pounds of anthocyanins, per hectare. You can change just one practice, go to regulated deficit irrigation. You're going to improve your anthocyanin production by about 70% in the hot climate. When you combine it with pre-bloom leaf removal, either with SDI or RDI, you're going to even make it better. But what changes the most is the production cost of flavonoids or phenolics in these vineyards. It can cost up to $1.56 to make 1 unit of anthocyanin, the way they have been farming. But if they change it to a leaf removal or a regulated deficit irrigation situation, the cost to produce anthocyanins goes to about half of what it is. So I showed this figure earlier. It's a summary of this, what leaf removal does, what it doesn't do, what applied water amounts do, what they don't do. But some of the results were, what we were expecting, like increasing light filtration earlier in the season, canopies more open, less skin pA concentration, less mean degrees of polymerization, more smoother vines. But in the end, if we were to look at the overall picture between these contrasting regions, we have little to no cloud cover. We have intermittent heat spikes and a general warming trend, and we have no increase in precipitation supply over the course of last 2 to 3 years, 2 to 3 decades. But what we're seeing is more shifts towards position, but sprawling systems. Larry Williams mentioned Iandolini's work, where they did some modeling between different row orientations. So we tried following up this work by looking at the berry temperatures when the rows were oriented 45 degrees from north or 135 degrees from north. So 45 degrees, this would be almost perpendicular to Route 29 in Napa. 135, this would be parallel to Route 29. What we're seeing is even with the positioned and sprawling systems, there's a huge discrepancy between how these berries heat up. If these rows are oriented 135 degrees, the clusters are directly exposed to sunlight, right? And the berry temperatures are in excess of 127, 130 degrees Fahrenheit. So they're hot to the touch. 45 degrees, these are it's more uniformly distributed morning portion and afternoon portion of heat gain. So the primary metabolism summary on the North Coast, leaf removal timing essentially had no effect on water status, net gas exchange, components of yield, and primary metabolites. Applied water amounts have more of an effect on the North Coast. We had a significant effect on our water status, net gas exchange, components of yield, primary metabolites, only on our total soluble solids. So when we try to summarize this, the applied water amounts, the severity, time and duration will influence the water deficits. We have an indirect effect on berry mass. The ratio of skin to pulp ratio should increase. So we did get a concentration increase in anthocyanins, concentration increase in flavonols, minor effect on proanthocyanidins. We did not see a whole lot of effect on canopy modification, ameliorated fruit exposure, and increased flavonol biosynthesis. There was no direct effect for stimulation of anthocyanin biosynthesis or gene activation with Cabernet Sauvignon. Canopy manipulation in the position, but sprawling canopies on the North Coast. We did only see an effect of light and temperature, but we did not see an increase in biosynthesis of anthocyanins. We did not see an increase in adaptive mechanism, but we did see an impact of light. Only this enzyme was upregulated, and we only saw an increase in flavonols with canopy modification. So overall, we do see that cluster microclimate on the North Coast without leaf removal was already optimized in the new trellis systems that we see. Clear skies, long periods with minimal precipitation, irrigation restriction does have a stronger effect than canopy manipulation. And optimal ET replacement is essentially between 50 to 60% of ET crop, using sustained deficits in this case. Although not as impactful, a lot of people are still wanting to understand how and if leaf removal does work in the North Coast. But that is what we found over these studies in contrasting regions. So with that, I can take questions, or I can turn it over to the next victim. Any questions for me? No? All right. This is a modified VSP. Oh, it's not pointing. Yes, sir.
I know one of the biggest benefits of corn leaves is for disease incidence. Do you see any increase in incidence?
The question is if we see differences in disease incidence. So this was a replicated study at a university. So we have the ability to use a lot of interesting chemistry for plant protection. But when we did our Michael study in Merced County, we had 9 leaf layers from site to site, and this was only managed with sulfur dust. So we did not see anything. I mean, even powdery mildew, and this was classic clone 1 of Merlot from FPS. The ones that we have on our campus turn like white, like kaolin, but because we don't dust them. But I mean, in your situation, that might be quite different. But for hot climates, we do not see a whole lot of effects on fungal disease incidence if we do not pull leaves, even in sprawling canopies. Well, that's what our other crop load work showed. Don't pull leaves, don't drop clusters, but I don't want them to run me out of Napa yet. So, Miss Bogart. Mm-hmm. This one?
You said that you saw an increase in the ratio.
Yeah.
All of his work indicated just the opposite.
Yeah, but Dr. Matthews was smart. He was working with Merlot. This is with Cabernet Sauvignon. So we saw the same thing with Merlot in hot climates. I mean, cultivars behave differently for these, extraction of these compounds by. No, that was with Merlot. That was the work he did with Castellarain. So I mean, Merlot responds very well to these, and you can do a lot of gene expression work, and publish all these great papers with. But with Cabernet, it's quite difficult to get these responses. You do see an increase, and that's how we saw the increase in anthocyanin concentration, not biosynthesis, in Cabernet Sauvignon. With Cabernet, I believe they do have a point. When Professor Matthews stopped by the Oakville station with Mike Greenspan, we got into a heated argument. Which is, not too far from reality. But there's a point. I mean, these people have vibrant businesses, and, they're very successful at it because, it works. They're not making this up. Yeah, I mean, there's a reason, a bottle of wine from Oakville is $260 a bottle on average now. Well, here's Oakville Cabernet. You end up with a higher anthocyanin concentration with very low tannins. That's what the consumer wants now. So if you want a little bit more astringency, they blend it with Cabernet Franc. but I cannot give away all our secrets. So, all right, I'll turn it over to the next guy.